Hello, and welcome to your mini lecture on alkanes, alkenes, and alkynes. These are all hydrocarbons, meaning they contain only hydrogen and carbon. We will look at how to name hydrocarbons in this lecture. There are several ways to write the chemical formula for an individual chemical. There are molecular, empirical, and condensed or structural formulas. Molecular formulas give the number of atoms of each element which are in the molecule. Empirical formulas show the smallest whole number ratio of the elements in the molecule. Condensed or structural formulas give some description of the structure of the molecule. All of these formulas are the correct formula for the chemical ethanol. Organic chemists spend a lot of time drawing organic molecule structures. After a short time, hand cramps will ensue, as most organic compounds are rife with carbons and hydrogens. In order to streamline the drawing of organic molecules, we will use line structures. Line structures have a carbon at each corner and at the end of each line. Every carbon makes 4 bonds, whether it's 4 singles, 2 doubles, 2 singles and 1 double, or even 1 triple and 1 single. If the carbon is shown bonding to 2 other atoms, be it another carbon or another element other than hydrogen, then the remaining bonds of the 4 carbon must make are being made with hydrogen. For example, the carbon at the end of the line on either side of the pentane line structure is making 1 bond with another carbon. The remaining 3 bonds are with hydrogens, which we do not draw. They are understood to be there. Likewise, at the end of each double bond pointing downwards in the isoprene molecule line drawing, the carbon is making a double bond with another carbon. The remaining 2 bonds are with hydrogens. Line drawings take a little getting used to. If you are going on to take organic chemistry after this course, you will be very happy to know how to do them. Alkanes are hydrocarbons whose carbons make 4 single bonds. In other words, there are no double or triple bonds in an alkane. Alkanes are said to be saturated. I like to imagine that they are dripping wet with hydrogens. The name of an alkane is based on the number of carbons in the chain. The first 4 chains, 1 carbon, 2 carbon, 3 carbon, and 4 carbons, have unique names, but from 5 carbons on, they follow the Greek prefixes as you have learned previously. Here is the list of the first 12 different length carbon chains, or alkanes, and their corresponding names. You will need to memorize these to be able to successfully name organic compounds. Alkenes are hydrocarbons that have at least 1 double bond. Alkynes have at least 1 triple bond. Alkenes and alkynes are said to be unsaturated. They have less than the maximum number of hydrogens possible. The ending of the name of alkanes is "ane", so it likely does not surprise you that the ending of the name of alkenes is "ene", and the ending of the name of alkynes is "ine". Sometimes a hydrocarbon can have both double and triple bonds. We will learn how to name those in the next lecture. The International Union for Pure and Applied Chemistry, or IUPAC, sets the rules for naming all chemical compounds and elements. In organic chemistry, the longest continuous carbon chain sets the suffix of the name. Any carbon chains or functional groups, which we will talk about in the next lecture, are placed into the name as a prefix. Carbon chains or functional groups, which branch off of the longest chain, are called substituents because they are substituting for a hydrogen in the bond to the chain. The names of the hydrocarbon substituents come from the alkane name, but you change the ane ending to -il. For example, here is shown a hydrocarbon which has 4 continuous carbons in the longest chain. This sets the ending of the name to butane. There is one hydrocarbon chain coming off of the main chain, and it has 1 carbon. The alkane with 1 carbon is called methane. We change the ane to -il, and the name of the substituent becomes methyl, which is the prefix. Put the prefix in front of the suffix and voila, you have methyl butane. When naming hydrocarbons that have substituents, it is also necessary to specify at which carbon each substituent attaches to the main chain. Here we see a hydrocarbon with 6 carbons in its longest chain. There is an ethyl group coming off of the main chain. Depending on which way you number the carbons, from left to right or from right to left, the number of the carbon to which the ethyl attaches could be 3 or 4. When there is a choice, always choose the lower number. The number goes in front of the substituent prefix and is separated from the letters with a dash. Therefore, here we have 3-ethylhexane. Here is another example of a hydrocarbon with substituents. The longest chain is 5 carbons long, and there are 3 methyl groups coming off of the main chain. If you have more than one of the same type of substituent, you use a Greek prefix to specify how many there are. If you number from right to left, the connection carbons are numbers 2, 4, and 4. If you number from left to right, the connection carbons are 2, 2, and 4. The sum of the numbers, which is lower, is the correct numbering. Therefore, here we see 2,2,4-trimethylpentane. Numbers are separated from numbers by a comma. Numbers are separated from letters by a dash. If there is more than one kind of substituent, put them in the name in order of the substituent name alphabetically, not by any prefixes. If you have a double or a triple bond in your hydrocarbon, the ending of the name will not be ane. It will either be -ine for double bonds or -ine for triple bonds. When there is a double or a triple bond, you must specify at which carbon the double or triple bond starts. The first example has a triple bond at the end of the molecule. The double or triple bond takes precedence over other substituents. By that I mean, if there is a double or a triple bond, number your main chain so that the double or triple bond gets the lowest number. So the first molecule is named 1-pentyne, sometimes called just pentyne as the 1 is understood. The second is 2-pentene, and the third is 1,4-pentadiene. The di accounts for the fact that there are 2 double bonds. This has been your mini lecture on alkanes, alkenes, and alkynes. Please go now to do the associated homework assignments. If you run into confusion, please ask for help. Help is always available.